Lesson 5 of Chapter 5 is on multiple angle and product to sum identities. We're going to break this lesson into 3 different days. In our first day, we're just going to focus on what we call double angle identities. Before we get into that, I've got a joke for you. Do you guys know how to take the number 7 and make it an even number? All you have to do is take away the S. Good stuff, huh? Okay, here's your double angle identities. We have one for sine, we've got one for tangent, and then we've got 3 separate ones for cosine. The reason these are called double angle identities is because you can see that each of them has the angle theta being doubled, multiplied by 2. So we're going to use those on problems like this. It's going to ask us to find the sine of 2 theta and the cosine of 2 theta, and they're going to give us the sine of theta. So the first thing I'm going to do is I'm going to draw a picture of a reference triangle. Now, this information right here is going to tell me which quadrant to draw my reference triangle. And since it's between pi and 3 pi over 2, I'm going to draw it in the 3rd quadrant. There's my reference triangle. And since the sine is negative 7/25, because my reference angle is right here, I'm going to put a negative 7 on the opposite and a 25 on the hypotenuse. If we use the Pythagorean theorem to come up with the adjacent side, we'd find out that it's 24. I'm going to make it negative because it's going in the left direction. So now we can use the sine of 2 theta. We've got an identity for that. It's equal to 2 times the sine of theta times the cosine of theta. And then we're just going to plug the values in from our reference triangle. The sine of theta is negative 7/25. The cosine of theta is negative 24/25. And so then if we multiply each of these, we would get our value, which would be 336 over 625. So there's the sine of 2 theta. Now we're going to go on to find the cosine of 2 theta. And we've got 3 separate formulas that we could choose from. It really doesn't matter which one of these 3 right here that we use. I'm going to happen to choose the bottom one. And the reason I'm choosing the bottom one is because then all I have to do is plug in the given information. The given information was sine of theta. So if I take 1 and subtract 2 times negative 7/25 and then square that, getting my answer, I will get, let's see here, that's 49 over 625. And then if we double that, we get negative 98 over 625. And then subtracting those would give us negative 527 over 625. That would be the cosine of 2 theta. All right, so that is given some information, draw a reference triangle, then use the information from the reference triangle with your new identities for double angles. Example 2 is now applying that double angle identity to solve an equation. So this one we're solving between 0 and 2 pi. And so hopefully when you look at this problem, hopefully this right here jumps out at you. We're going to change that into 2 times the sine of theta times the cosine of theta. And then if I write the rest of the equation, now we got 2 terms being subtracted. We can factor a sine of theta out. If we do that, we're left with 2 cosine of theta minus 1. And now that I've got it factored, I can set each factor equal to 0. That's going to give me cosine of theta equals positive 1/2. And now looking on my unit circle for my answers, sine is equal to 0 at 0 and pi. And cosine is equal to 1/2 at pi over 3 and 5 pi over 3. So we have 4 answers. Here is another problem where we're solving between 0 and 2 pi. This time, if you look closely at this problem, hopefully the cosine of 2 alpha is going to jump out at you. We've got 3 separate formulas that we can use to change that. I'm going to choose the one that only has sines. Let me go back to those identities again right here. So if I just erase this, I'm going to choose to use this bottom equation because it only has signs. And why am I choosing to use that? Because if you look at the equation, my equation already has a sine squared in it. So 1 minus 2 sine squared is going to equal negative sine squared. Now, like I've shown you, if you want to change this into 1 minus 2m squared equals negative m squared to do the algebra, feel free to do so. I'm going to add 2m squared to both sides. That's going to give me 1 equals just m squared. Then I'm going to square up both sides, and that's going to give me plus or minus 1 equals m. Well, now I'm going to change that m back into a sign. So I've got the sign of a equals positive 1, and I've got the sign of a equals negative 1. Sine equals 1 at pi over 2, and sine equals negative 1 at 3 pi over 2. So 2 answers to this problem. Another example, this one involves a tangent. If you look closely at this one, we've got a tangent of 2 beta equals 2 times the tangent of beta. So again, hopefully when you look at this, this is standing out. We have a formula for that. We're going to change that into 2 tangent of beta over 1 minus tangent squared of beta. This equals 2 times the tangent of beta. Again, what I just did right there is I used this identity right here. Okay, now what I'm going to do is I'm going to eliminate my fraction. I'm going to multiply both sides by 1 minus tangent squared. And if I do that to both sides, then I'm going to be able to cancel this with that. And so it looks like I'm left with 2 tangent of beta equals 2 tangent of beta times 1 minus tangent squared. Well, again, if you want to use m's, I'm going to distribute on the right-hand side. It's going to give me 2m minus 2m cubed. I'm going to subtract 2m to both sides because we've got like terms. That's going to give me 0 equals negative 2m to the third. And so if I divide both sides by negative 2, and then cube root both sides, that's going to end up giving me 0 equals m. Well, m was a tangent, so now we only need to solve tangent of beta equals 0. And so that answer would be 0 and pi. Just 2 solutions on that. So this first day of lesson 5 of chapter 5 is on using double angle identities.